gracious, it's hot. Of course, I've been walking around like crazy. Okay. Any questions? Let me just go over a few things. I've said some of these before. I'm saying it mostly for people who will be listening to this. One big deal is Fridays. I'm not going to Birmingham anymore because, as far as I know, the B building's still closed. So I'll be here on Friday mornings, 8 to 12 at least. I'll probably be here after 12. Okay. So this Friday I'll be here. Now, I really think we need the review session on Monday because we're not making nearly as much progress in module 14, because I had to return all those papers this morning. So we're not going to get all of 14 covered that we need to, but let's do what we can. So hopefully most of you will be able to participate in the module. Was there anything else you need? Is that all? Okay. If after class, if you'll hang in, I'll give you your papers back. Okay. Oh, let's see. No, I put them all on your desk because your stuff was here. Okay. Good deal. So, but it's up to you if you really want to take the test at 8 o'clock on Monday, 8:30 on Monday. That's up to you. Okay. Otherwise, we'll be in a review session from 8:30 to 10:20. Okay. And then after that, any time after that, you can take the test at any time you want to. I'm sorry?
So you can take it right after
Right after that will be fine. If you don't have a class, he had a class then, a final, which I thought Tuesday, Thursday, the odd number hours are on Wednesday, but he may be graduating. I don't know. That's the other thing. Are any of you graduating this term? Okay. That would be quite problematic because graduate grades have to be in by noon on Tuesday. So you would be required to take your test by Tuesday morning so I could get the grade in. But I didn't think any of you would be graduating. All right. Yes. Huh? He is? Okay. That's right. I thought there was at least one. But we'll work it out. I've had him in classes before, so I think he is confident to let me know and we'll work that out. Okay. Good. I'm glad you said that. So, any questions? Either math questions. Remember, for your final exam, I'll say this again Monday, I recommend you do a formula and equation sheet, but you can't use it because the final exam is standard, for both campuses, all Math 100 classes, and they don't allow it, so I can't allow it either. But it's still the best study tool I think you've got, is to do a formula and equation sheet, but you just can't use it during the test. The act of doing it is really active learning, and if you get that all organized and stuff on paper, more than likely it'll be organized in your brain as well. Okay. Any questions? All right. Module 14 is talking about quadratic equations. And what do we mean by quadratic equations? Equations whose maximum exponent is 2. Okay, polynomial equations whose maximum exponent is 2. And in this section, 14.1, we're doing solving quadratic equations by factoring or by taking square roots. Well, 14.1A was factoring. 14.1B is taking square roots. So that's what we're going to do now, solve quadratic equations by taking square roots. Okay? Now, here's one. Consider the quadratic equation x squared is equal to a. That equation can be solved by factoring. Is x squared equal to 25, for instance? Subtract 25 from both sides. That leaves a 0 over here. That's factorable. X plus 5 times x minus 5 equals 0. Then set this one equals 0. That gives you x equal negative 5. Set that one equals 0. That gives you x equal positive 5. Solutions are plus or minus 5. Okay? Now, solutions that are plus or minus the same number are frequently written with the plus or minus sign in front, and you only write the 5 once. Okay, like this. Solution is plus or minus 5. I say it that way, that's how I usually write it. Or you can write minus 5, plus 5, plus 5, minus 5, however you want to do it. This fact suggests that solutions that started like this, if your equation started like that, all you'd have to do is take the square root of both sides of the equation. Here is the warning. Most of time I do it, and most students do it, x squared is equal to 25, take the square root of both sides, x equal 5. Go on to the next problem, right? You missed half of it because it's plus or minus 5, okay? So that's the danger in taking square root of both sides. We forget about the minus, okay? So if you remember that, it's much easier to do that than all this. But this is almost sailor proof or student proof. If you factor it, move it over, factor it and stuff, you'll see both answers and you'll most likely remember it. Okay. However, if this had been 24 rather than 25 or 26 rather than 20, or any non-perfect square, then all you can do is plus or minus the square root of that. If that's a perfect square, yeah, doing this, factors, everything is great. But if that's not a perfect square, it's still a solution, plus or minus the square root of a, whatever your a is. But you've got to remember your plus or minus sign, right? Any questions? All right. Test 4? Okay. Now, some are down the hall here in 251, so if you don't want to go back down the stairs, it's a little closer, but it's up to you. Test 4. Okay, there we go. All right, and then when you turn that in, be sure. Come here just a second. Okay. When you finish that, bring it back and let me give you all your papers back. But if class is over before then, we'll get it later. Just come by my office during office hours, so I'll give them to you. But bring your paper. All right. Okay. So, here's the principle of taking the square root of each side of an equation. It's pretty simple. If x squared is equal to some number a, whether that's a perfect square or not, then you can solve this by taking the square root of both sides. Square root of x squared is x, and the square root of a is plus or minus the square root of a. You've got to remember to do the plus or minus. Okay? So, if x squared is equal to 3, what would be your solution? Plus or minus square root of 3. X squared equals 16? Which is 4. See, we don't know what the square root of 3 is, so you just write it that way. But if you know the square root, go on and take it, but remember to do the plus or minus sign. Does that make sense? All right. Now, we've got another example to do, and it's a pretty important one, okay, because it reveals something else you've got to do. And why they left this off, I'm not sure, but they did. Woo. Okay. What if you had a problem like this? 3x squared is equal to 36. Second? All right. What would be your approach in a problem like that? Yes. You isolate the x squared. Even though that's a perfect square, and it would feel really good to take the square root of both sides there, you can't take the square root of, that's a coefficient. It's not going to work. So you're going to mess up that being a perfect square, but you've got to isolate this. So how do you isolate it? Divide both sides by 3, which is doable, and that gives you x squared is equal to 12, and then what do you do? Okay, and that would be plus or minus the square root of 12. Are you through, folks? No, why not? There's a perfect square hiding in 12. What is it? Okay, square root of 4 times what's left? Square root of 3. And what is the square root of 4? 2. Plus or minus 2 root 3. There's your answer in final form. Glorious final form. Okay? This is a correct answer, but it's not complete. Okay, that is a complete answer, correct answer, but not complete because you can't take the square root of 2. That is your best answer. These would probably lose you a point, at least. That will get you full credit. Okay? So always carry out, simplify your radicals, just like we did in the last chapter, module. Okay? Okay.
Whatever it is.
Huh? Yeah, whatever it is. Okay. Any questions on that? Or you could write that 2 root 3, comma, negative 2 root 3, or negative 2 root 3, comma, 2 root 3, whatever. All right, now I think we're ready for this one. Okay, how would you proceed here? Second? Okay, good planning. What we're doing is isolating the x squared first, so we add 72 to both sides. Okay, and that gives us 2x squared equals 72. Now what? Divide both sides by 2, and that gives us x squared is equal to, help me, what's half of 72? 36. Hey, what does that give us? Say again? A little louder. What's the answer? Yes, x is equal to plus or minus 6. Okay, perfect. Now, that indicates you could have factored that to begin with. Okay? If we had done this, factored it, you'd factor out a 2, and that would leave you x squared minus 36 equals 0, and that would be 2 times x plus 6 times x minus 6 equals 0, and certainly 2 can't be 0, so divide that out, and then you have x plus 6 equals 0, or x minus 6 equals 0. This gives you x equal minus 6, and this one gives you x equal plus 6. Okay, so you could do it either way. That one was factorable, but since you said divide by 2, or add 72, fine, you can do it that way. Either way works, either way is acceptable. Whatever you see best, because this one happened to be a perfect square. If that hadn't been a perfect square, then you almost have to do it the way we did to begin with. Okay, so that may be the most efficient, since you don't have to back up and say, nope, this won't work. All right, there's a check your understanding at the bottom of that page. Please use those as soon as possible after class. And let's move on to, let's see how they did it. Sorry, jumped the gun a little bit. Let me erase what I wrote, and let's see what they did. Solution, you write it down again. That's a good waste of effort, okay. And they did what you did, added 72 to both sides, then they divided by 2, get x squared equal 36, and then they took the square root of both sides, and that gives them x equal plus or minus the square root of 36. I'm glad they write so many steps in here, and that gives you x equal plus or minus 6. Good deal. Now, let me just warn you on this, okay? I saw it happen more than once, which means it's too much. Not very frequently, but I did see it happen on the test and probably the quiz too from the last thing. When you take the square root of 36, then you write it down as the square root of 6. No, when you take the square root of 36, it's just a 6. And I think several of you, if you got your papers back, you'll see you made that error. You didn't always make it, but occasionally you did. So please don't do that. If you take the square root, you're through with it, okay? So don't leave the square root sign there longer than it needs to be. Okay, so that's that focus. All right. There's a solution 6 and negative 6. Oh, they really covered a lot of ground here, didn't they? Okay. So let's do the top of page 5 in module 14. What do we do with this? 2 times x minus 1 squared minus 36 equals 0. Oh, man, what are we going to do with that? You do have two choices here. And was someone saying something?
I think we should go ahead and work out the parentheses.
Do what?
We should go ahead and work out what's in the parentheses first.
Okay. Even though that's not going to guarantee you a solution, okay, I tend not to think that's a good idea yet. If we were in a regular time and weren't short of time, we'd do it just to show you that it's not going to be a good idea. Okay? And I may eat my words later, but let's now, just like we did before, isolate this. Isolate the square. Just like we did before it had something added or subtracted to it. So let's isolate this. So what would we do first? Add 36 to both sides. And do what? And no, that's not added. It's multiplied. Okay? So let's just take it a step at a time, one bite at a time here. Talking about Fritos. Okay. 2 times x minus 1 squared. These go to 0 is equal to 36. Now you what? Divide by 2, not subtract. Okay? Divide by 2. That gets rid of that. And you get x minus 1 squared is equal to, what's that? 36 divided by 2. Help me. Real quick on the math. Huh? 18. Excellent. Okay. That's why I said I don't think factoring will work, because I had already sort of done that mentally. Now what do we do? Square root of both sides. Let's do the square root of this and the square root of that. But when you take the square root of a number, it's always plus or minus. And what's the square root of x minus 1 squared? X minus 1. Perfect. And don't hang on to the square root sign, okay? And what's plus or minus square root of 18? Is that how you want to leave it? No, that's the square root of 9 times the square root of 2. And what's the square root of 9? This is x minus 1 plus or minus 3 root 2. Not a square root of 3, by the way. And now we finally add 1 to both sides. And that gives us x is equal to, because these go away, 1 plus or minus 3 root 2. And that's a perfectly legitimate way to write an answer. Another way would be 1 plus 3 root 2, comma 1 minus 3 root 2. Write them as two separate answers, or just be lazy and write them as 1 plus or minus 3 root 2. And you see, this isn't going to be something that you could have factored. So multiplying out would have given you something you could factor, guaranteed. So that's why I said let's not spend class time doing it, because I could tell it wasn't going to work. Okay? You may not always be able to tell that, but I was looking at it and thought, no, that's not going to work. So, got it? That's a good answer. Perfectly correct. No better than 1 plus 3 root 2, comma 1 minus 3 root 2, that's fine. If you really feel, if this was a real life problem and you really needed something you could measure, I can't measure 3 root 2, you could do that on a calculator and round it to some digits. But that's an irrational number. It's never going to round perfectly. Okay. Boy, they have a check here that I'm not sure I would have even thought of doing. But you can certainly do it. Read it in the book. We're not going to take class time to do it. It's always a good idea to check your solutions, but that one's a real hairy check. Okay, I haven't been noticing they do checks for most of these. All right, now let's move to focus on solving, and this one isn't in the slide set, so we're going to have to do it here. X minus 6 squared is equal to 12. Okay? Now again, you might be tempted to go on and square that, expand it, and then try to move things around. I'll tell you now, you won't get a rational solution. Okay? In other words, you can't factor it. So since we don't know what else to do, let's do what this says, taking square roots. So what would you do? Take the square root of both sides. And when you take the square root of a number, you always do plus or minus. Okay? What do you get on the left? X minus 6, and on the right? Take it. Okay, you said plus or minus root 12, is that what you said? I couldn't hear what you said. Okay, oh, you're already doing that. That's a good idea. Square root of 4 times the square root of 3, which is plus or minus 2 root 3. I shouldn't have written that over there. Now what we're going to do is isolate the x, so that's going to be adding 6 to both sides. I'm sorry, I skipped a place here. It'd be x is equal to 6 plus or minus 2 root 3. Simplest way to write the answer. Could write it as it is two solutions. Excuse me. Okay. Excuse me. Okay. It's x equal 6 plus 2 root 3, comma, x minus equal 6 minus 2 root 3, if I could talk. Okay. There is a check your understanding there. I highly recommend you do it. And then there's the practice problem, practice problems at the end, 5 of them. Please do those. They give you precious few to do, so please do those. That way you'll be better equipped when it's test time. And we aren't going to have a test on this module. That's going to be in the final exam, okay? Final exam, I'm afraid, is going to be long enough, so I can't test you separately. Okay. All right, any questions? Yeah. Okay. So let me get through all this. Okay. And move on to Module 14.2A, which is coming up next. All right. Slideshow from current slide. Okay. We're still in Module 14, which is quadratic equations. Now we're going to do another technique. And it's not my favorite. There's lots of steps in it, but it's really important to know because as you go further in math, you're going to have to come back and do this technique in other contexts. So get this down, okay? This also enables you to find the shortcut, but you can't go straight to the shortcut without doing this logically anyway. So Objective 14.2A, solve quadratic equations by completing the square. Now, just a little bit of review. What makes a perfect square trinomial? Perfect square here, perfect square there, meaning both of these are positive, and then the middle term is exactly twice the square root of these two. So the square root of this is x, square root of that is 3. Twice 3x is 6x, okay? Perfect square here, perfect square there. This is twice the square root of those two, but this time we use minus 5 as the square root. So x minus 5, twice that is minus 10x, okay? So this is x plus 3 squared, that's x minus 5 squared, okay? So, remember it was a long time back we were doing that. And And y'all were quite good at it, if I remember, okay? So for each perfect square trinomial above, the square of 1/2 of this number, the b. Take half of 6 and you get 3, you square it, you get 9. Take half of -10, you get -5, you square it, you get 25, okay? That is going to be the key here, how you proceed with this technique. All right. We just did that, so I think we're okay. Any questions? All right. This relationship can be used to write a constant term for the perfect square trinomial, and adding to a binomial the constant term that makes it a perfect square trinomial is called completing the square. Okay? We make up a square somewhere where there wasn't one before, is what we're doing. So here's a quadratic equation. This is a form of a quadratic equation, not the standard form, but a form. X squared plus bx plus c is equal to 0. Standard form would have an a here. We're going to do it the easy way first with a 1 there. X squared plus bx plus c is equal to 0. Now, of course, x can't be 0. That would be a quadratic equation. Okay. Now, if that one can't be solved by factoring, in other words, there's just no way you can split up the c and the b's and stuff to make it complete. What we used to say is cannot be factored or non-factorable or prime or something like that. Now we're going to find a way that you can still solve it, and that's called completing the square. Here's the procedure we're going to do. Okay? It's unlike what we normally do. So what we're going to do is, I hate it when they do this, okay? It says write this like this. That's incorrect. It would be a minus c over here. But they say write it in the form of this, okay? So, I don't like for them to say that, but what they're getting at, isolate the terms with x's in them and the others put somewhere else, okay? Now, once you've isolated that, then what we do, if you remember back from the previous slide, take half of b and square it. Add that here, but if you add it here, you add it over there as well. So add to each side of the equation the term that completes the square, and that's going to be 1/2 b squared. So that's the next step. I really don't like the way they're doing this, but when we do it in person, it'll be easier, I think. Factor the perfect square trinomial, write it as the square of a binomial, take the square root of both sides, and then solve for x. So basically, it's what we've already been doing, but we just got that first step and second step in there. For the method of completing a square to be used, the coefficient of the x squared term must be 1. Okay? It's not quite completely true, but for now we'll do it. If it's not 1, then you multiply each side of the equation by that reciprocal of that coefficient of that, and that is illustrated in the next example. So we're going to get to that one later. They really are a little awkward on this. So let's do this one. Let's see. They may have an example before they get here, do they? Actually, they do. Let's back off. Well, let's just do it here. Before we do that, okay, before we get to this one, here's a couple of other things. Here's an x squared plus 8x plus 16. The question is that a perfect square binomial?
Yeah.
Yes, it is. Perfect square. The square root of this is x, square root of that is 4, twice 4x is 8x. Yeah, so that is a perfect square. One more example we didn't have on the slide set, okay? Now, next thing they have you do is complete some squares. Here's an x squared minus 8x. Now, all we're doing now is completing the square. So how do we go about completing the square? Take half of the linear coefficient. Okay, there's the quadratic, this is linear. take half of the linear coefficient. What is that? -4. And then you do what? Yeah.
Put it on both sides.
Okay, yeah, you square it and add it to both sides. This doesn't have but one side, we're just completing this square. That's all we're doing here. So you take half of 8, -8, that's -4, square it is +16. You just completed the square. Okay, just like what we did there, okay? How about this one? Y squared plus 5y. How would you complete that square? This is a big ooh. Okay? Why? What is half? Say again?
Can you do that?
Yes. Half of 5 is 5 halves. Right? That's a fraction. Fractions are still real numbers. Okay? We love them, right? Yes. Okay? And then what you do with that? Square it. So that would be, and what's the square of 5 halves? Square of 5 is 25. Square of 2 is 4. That's a perfect square with a fraction involved. Ooh, boo hiss. But it still works. It still works. Okay? That's the important thing. Okay, what I didn't do before is write this. So this is x minus 4 squared. And this is x plus 5 halves squared. Okay, good deal. Are you up, or do you need any more? Test 4, okay. Put this here. Okay, and then when you do come back, finish whatever, I'll need to give you all your old papers. Now, if I'm in another class, we'll have to wait till office hours to do that. But, okay. Test 4. There we go. And you did turn in the quiz 4, didn't you? Okay, good. Okay. All right. So, here's the rule. Take half of this, -4, square it, +16. Here is a hint, folks. It'll come in really really handy later. Maybe happy too, but handy later. And what you'll do, as soon as you take half of that, write it here. Half of -8 is -4. So put x minus 4. You already got it done. Then you complete it, and that will work. Half of this is 5 halves. So y plus 5 halves will be your perfect square. It is the square of the bottom. Okay? You'll see where that comes in handy later, but you still have to do this. You know what that's going to be at that point. Okay. Now they do their little verbiage, and now we're ready for, whoa. No, we're not. They do another example before they get to it. So let me clear the slide. Okay. Before we get there, here's another one. Solve by completing the square. Okay, we're going to try to use those rules. X squared minus 6x minus 3 is equal to 0. What would be your first approach? Anybody? Say again?
She said add 3.
Okay. That's absolutely what we're going to do. First thing I always think of, can I factor that? And I'll tell you now, no you can't. Okay, so since it can't factor, now we're going to proceed with completing the square. So what we're going to do is add 3 to both sides. Okay, so that gives us x squared minus 6. Now here's the thing that I do that the book doesn't do. Put a big blank in there. Notice how obnoxious it sounds, is equal to 3. Leave a blank there. It just makes life easier. Okay? Now what do we do? Take half of -6. That is a -3. And then you do what? plus 9. Well, you just changed the left-hand side by adding 9. You must also add 9 to the right side. Otherwise, it's a different problem, folks. Okay? You see, we now have the same problem we had before. Okay? Now, as soon as you take half of that, you could write down part of the answer here. X, when you take half of minus 6, it was minus 3 squared. There's the left-hand side right there. The right-hand side is 12. Now what do we do? Anybody? Square root of both sides, and that would give you? Is that all, or you got more? No, is that it? Okay, good. Okay. And if you have any papers I didn't return to you, you can come get them either after class or during my office hours. Because I think you were out when I was passing out some of the papers. Okay. Okay. You said take square root of both sides, and what do you get there? X minus 3 on the left is equal to plus or minus 2 root 3. Boy, she went right for the juggler, right? She said, what is the square root of 12? Well, that's 4 times 3. Square root of 4 is 2. Square root of 3 is square root of 3. So plus or minus. Don't forget the plus or minus 2 root 3. Now, if you want to take more steps, by all means, take more steps. Don't cheat yourself by trying to skip too many steps. Take as many steps as it needs for you to see and make sure and know you've got the right answer. But we're not through yet, are we? What do we need to do now? Add 3 to both sides. So now you get x is equal to 3 plus or minus 2 root 3. Simple as you can write it. If you wanted to, you could write it as x equal 3 plus 2 root 3, comma, x equal 3 minus 2 root 3. Either way works. Okay? They're both correct answers. Oh no. It's happened again. Gabron came. No, we've run out of time. Okay. Does that bring you up to speed then?
Yes, sir.
Okay.
I just owe you the paper now.
Huh?
Just owe you the paper.
Okay. Yeah, you got to get the paper. Okay, now, for those who weren't here when I was passing out the quizzes and tests, you can hang here and I'll get them. Let me say, are there any questions about this? Okay, where we're going to have to pick up on Monday. Monday is a review session, not the final. And we've just done that, and we'll pick up with this at the top of page 8 of module 14. Okay. So let me end this.